All right, Libby, Eli, and is that it?
Yep.
Libby and Eli. All right, we're starting chapter 5 review. They have said let's do like one from each section together. So like number 1 together, number 3 together, number 6 together, number 8 together. Do you want to do them right in a row, or do you want me to do 1 and pause for 2?
Yes.
Do 3 and pause for the other 2. Okay. All right, so number 1. Here we go. Find the absolute extrema. The only points that are going to give me an absolute highest and lowest point are checking the endpoints, and checking critical numbers. So, left and right endpoints, if I have a closed interval, okay, do you guys know what I mean by closed interval? He is closed. He's not going from negative infinity to a positive infinity. He has a left and right endpoint, okay? So we've got to check those guys, and we got to check any critical numbers in between, okay? And we're trying to figure out which one's the highest and lowest. So absolute maxes and absolute mins, okay? At -4, this point is -4 comma something, and at 0, he is 0 comma something, right? Okay, how do we figure out the something? Plug it into the original, right? -4 squared is 16. 5 times -4 is -20. So this would be -4, yeah? Okay, now I plug 0 in. 0 squared is 0, plus 5 times 0 is 0. So this is 0, 0, yeah? How do I find critical numbers in between?
Set it equal to 0. Or you do
The derivative. We take the derivative equal to 0. What's the derivative?
2x plus 5.
2x plus 5 equals 0. Subtract the 5. 2x equals -5. Divide by 2. X is -2.5. So my critical number is -2.5. Let's plug him in to figure out what his y-coordinate. Where do I plug him into?
The original.
The original, right? -2.5 squared is a positive 6.25.
What?
2.5 squared
Oh.
is 6.25.
Okay.
5 times -2.5 is 10 plus 2.5 is 12.5. -12.5. 6.25 minus 12.5 is -6.25. Okay, so we want an absolute max and an absolute min. Where's my absolute max at?
0,
0, 0. That's my highest point. So I'm going to put abs max here. Abs min?
-4, 4.
Yep.
-4, -4.
Abs min. So, if you care to know, he looks like this.
So if it was
Right? This is my highest point, this is my lowest point. That's what he's
if it was
looking like.
parentheses, would we include the endpoints?
No. So if this was parentheses, it would be an open interval. So basically what I would have is open dots here. So you would not necessarily need to plug these in. You would just be looking at this point in the middle. Right?
So we wouldn't have an abs max.
Right. Right. Now, you might still though, Reese, you might still need to plug them into the original to get these coordinates so that you know whether he's an abs max or abs min in the middle. Does that make sense?
Yeah.
Because otherwise you would have no other point to judge him off of. Does that make sense? So you might still have to find these coordinate points, but those itself could not be abs max and abs mins because they are. Why?
No, we can do that.
It's ickier.
Yeah.
It's not. It's
Yeah.
not ickier. Just
The derivative might be ickier. Okay, you want me to pause?
0 minus 0 is 0.
Yes.
Okay. All right. So if you're watching this video, you can skip ahead to the next problem 3 when we start that one.
Minus 9 is 0.
I'm gonna go over here.
Do we have
Maybe
more than one?
you might have more than one critical number for sure. Yeah.
Oh no.
You know how to take the derivative of the square root of x. You remember?
2/3.
No.
X to the 1/2 power.
That'd be 2
1/2.
minus 4
Still a
ninths.
power rule. 1/2 comes down in front and it's to the -1/2 power, which means he goes down below.
Is this the cubic root or is it 3
Square.
times?
It's 3 times the square root.
So it's 3 halves.
So it's 3 halves. Get your derivative and I'll check it with you.
4 ninths.
Minus 9 and 0?
Oh, your critical number is 4 9?
0?
Yeah.
Okay. Critical number. Okay.
Yes. So I'm saying equal to 0. Find your critical number. Yep. You are exactly right.
It's annoying that my fraction is
Are
like
both things
all the way
0?
at the end. Why? Both of them.
Both of their y's are both 0.
We have
This is kind of an illustration of Rolle's theorem, actually. Right? Since they're both the same and they're both at 0, this is an exact illustration of Rolle's theorem. Basically.
Wait, the 3 halves go in front, don't they?
But the square root of x goes in the bottom. So you can do like 3 over 2 square root of x.
I have to put the negative half right up at the top. Cause if 3 times square root of x, if that's the same as x to the 3 halves, bring that to the front.
Is that the derivative? Wait,
What I put back here.
derivative is
Three,
but
three
it's
times
not
x
like your
and then
derivative
negative one.
But
But I want them to be a positive 1 half power and then down below.
to get started.
So I take times yourself 3.
Okay.
X. So divide by that 2.
I think I'm doing this wrong.
I don't know how to math.
I have 2 is equal to, or
Yes,
3 is equal to
but
2
also
square root
have
of
2
3.
ends.
So far, is that right?
Yes.
Does x equal, what does x equal? I want to say over 2.25.
Geometry, I'm lost.
And then you plug that back in. What'd you get for your critical number?
She's working on it. She's trying to do that a little bit.
So I,
There is 2 options, but there's only 1 correct one.
Yes, that's
Gotcha. I gotcha.
why is there a syntax error?
Wait, is our answer for the mean value theorem just what x equals?
Is it 2.25, 2.25?
Yes. Yes.
Yeah.
You have to find your slope. And you have to set your slope equal to, or your derivative equal to slope. And then
What
whatever
did
the
you guys get for the derivative, or the critical number?
2.9.
2.25, comma 2.25?
4 divided by 9?
Okay, are we ready for 3?
Wait, that was it? No, that's not it. What do I do now?
2.25.
I'm pretty sure. The answer is 2.25.
Is that
That's our
the
critical number.
max? Is that the average?
For what?
It should be 9 over 4.
Yeah. That's what 9 over 4 is. It's 2.25. Yeah.
What did I do wrong then?
What are you talking about?
What did I do wrong
You got
then?
4 over 9.
Oh, you got 4 over 9?
Like if you like me to do it, tell me.
Is that the max though?
Add it to 1 over.
Okay, but the problem is, yes. Okay, I see what you did. If you get rid of the 2/3, this x is still on the bottom.
I'll be right back, I'm sure, I promise. I'm
Right.
going to go eat my lunch.
That x is still on the bottom, even if you get rid of the 2/3, there's still a 1 there. So it's just a flip of it. So what I would have done is go back to here, and instead of getting rid of the 3 over 2, multiply by the square root of x over. Right? And that gets rid of him here, so you have 3 over 2 equals the square root of x, and then you square. The x is still on the bottom. If you get rid of the 2/3 or the 3 halves, whatever, the square root of x is still on the bottom. Yeah. Okay. All right, are we ready for 3? Three is Rolle's theorem. Okay, here's the check for Rolle's theorem. Number 1, your endpoints. Verify that endpoints are, I'll say, have the same y coordinate. Okay, so like on a graph, they would be like directly across from each other, directly horizontal from one another. That's the first step in Rolle's theorem that you have to do. You have to make sure that they're directly horizontal from one another. So it doesn't necessarily have to be that they're both zeros. They could both be 4, whatever, right? But they have to be the same y coordinate so that we know they're directly horizontal from one another. Number 2, if they're directly horizontal from one another, what will the slope of that line be? 0, right? So we set the derivative equal to 0, right? Because we're trying to find where the hump and bump in the middle is also 0, okay? And that's number 2 for Rolle's theorem. So here's the deal. It says, verify that the right and left endpoints have the same y coordinate. That was step number 1. Then find all values of c in the open interval such that the derivative is equal to 0. If Rolle's theorem cannot be applied, which does happen, on the open interval. Explain why not. Okay, so what do we do first on number 3? Plug in. If we plug in 0, 2 times 0 squared minus 7 is 0 minus 7, which is negative 7. 4, 2 times 4 squared minus 7 equals 16 times 2 is 32 minus 7, which is not negative 7. It is 28. No, it is, I don't know, I can't math. 25. 25.
Negative 7 does not equal 25.
Yeah, so what do we put for number 3? Rolle's theorem does not apply. Not same y coordinates. They don't have the same y coordinates. Or you can put negative 7 is not equal to 25. Perfect.
Hang on. 2 to the 4th squared minus 3 to the 4th is equal to 25.
I can't get a slope for
2 times 4 squared.
Absolute value.
What?
Wait, why are we minusing 7?
Okay, so look at 4 and 5.
Wait, hang on, I'm confused.
What?
If you zoom in.
Oh, here. Let me zoom out quick, Jose. For Rolle's theorem, we said number 1 was we had to verify that they had the endpoints that they give me,
Yeah.
0 and 4, have the same y coordinates, so they're directly horizontal from one another. So this one we plugged in.
Yeah, but it's from 2 to 6.
Oh, I know what I did wrong. I'm on number 6. I was looking at 6.
Oh, yeah, there you go.
But it's okay. Yeah, you're right.
Give me just a second. Sorry. They both had the same like plug-in stuff, so I just went with it.
Oh, gotcha.
Actually, I don't think that even works. Does it?
Yeah.
I mean, that one doesn't work.
Can't apply to Rolle's theorem.
No.
So number 5 does work because they have the same y coordinates. So now we move. Step number 1 is verified. Check. Now we set the derivative equal to 0 to find the places where he has a hump and a bump. Okay. Okay. So do step number 1. If you get past step number 1, if it works, then move on to step number 2, and that's it. And you're done.
Is this one where you can, do you have to do the simple trinomial, or do you have to do the complex? That's
The complex trinomial.
Gross. I forgot how to do that. Is it this times this?
Yep.
3 times 3?
Yep.
So
9. Positive 9, negative 1. In the middle.
Question about people. When they like submit the whole like, oh, this person is whatever, can you like see their reasoning for why they picked the like player of the week or whatever that is?
I can.
You can? I want to know if Streff picked me because I was like the last person not to be picked for that. That's why I was asking that.
Why do I not know how to do a complex trinomial?
So now we're doing 5?
Let me see what you have.
I know you have to do these, you have to do 9 and 1, but like how do I write out the, like
Where
what do I
negative
keep and
9
what
is
do I
not
not?
included. So it's just
I need 9 and 1, but
So
where do I
this guy,
plug it in?
3x squared,
That stays.
this becomes plus 9x minus 1x. Right, because 9x minus 1x would be
Oh, I did that wrong.
minus 3.
Got it. I don't know what stayed and what didn't stay.
Okay, so I have my critical numbers.
That's it. Oh, except, do both of those live in an interval? You do.
Does it count if it's that?
Yes, if it's a bracket. Yes, then you have 2.
You said it's
Yep.
Verify, and then find all values and see both of them. Okay.
Ellie, what is that for?
What?
The thing that you just played.
Need help?
Yeah.
Okay.
Delicious.
So x equals 1/3 and x equals 3. What you got?
Dang it.
X equals 1/3 and x equals 3. Negative 3.
And you set that to 0?
Yep, so he's a complex.
Is that all?
So that's what they're doing right now, like, struggling. So
Yeah,
how much are we
know.
gonna take 3 times? Negative 3. Negative 5. Okay, so it's, Ready for 6? Ready for 6?
Okay.
Yeah. Number 4. What'd you guys get on number 4? Real quick. Rolle's theorem does not apply?
Yep.
Because, okay, check this out real quick. When you plugged them in, you got 2 different numbers, yeah? Rolle's theorem does not apply. But also, what's happening at 1? At x equals 1, he has a va. Which means I have a problem between -2 and +2. He's going to have like a icky part, okay? So one other thing that I should add at the top here is make sure he's diffable and continuous. Make sure he's diffable and continuous. Maybe that's like before step number 1 even, okay? So on 6, before we start step number 1, is number 6 going to be continuous and diffable? Number 6, is he going to be continuous and diffable? He's a quadratic. We're going to have any problems with quadratic? No, so he's continuous and diffable.
Like,
Number 1.
Stop.
Yep.
Like, quadratic half.
His parent function is quadratic.
Oh. Okay.
Yeah. And quadratics don't have vertical asymptotes. They don't have holes. They don't have jumps. They don't have anything like that. Yep. So he's continuous and diffable. Step number 2, or step number 1, really, after we do that, okay? We have to find the y coordinates and find the slope. Now, on 6, I find the y coordinates. So I plug in 0, 0 comma something, right? If I plug in 0, 2 times 0 squared minus 3 times 0 plus 1. 0, 0, 0 comma 1. Yeah? Now I plug in 4, 4 comma something. Right? Is it going to be 1 also? No, that's for Rolle's theorem. They're going to be the same y coordinate. This is not going to have the same y coordinate. So 2 times 4 squared minus 3 times 4 plus 1. 4 squared is 16. This is 32. 32 minus 12 plus 1. 21? Yes. So 4 comma 21. Cool. All right, now what do I do?
Now, we go about
We found
finding the slope.
We find the slope. M equals y2 minus y1 over x2 minus x1.
20.
20 over 4, which is 5. Okay, now what? Step 2,
We set equal to slope.
the derive equal to the slope. Okay, this is a little bit confusing when they say it up here. They say f prime of c equals f of b minus f of a over b minus a. Do you see that notation that they use? This means your derivative. This guy means your slope. That's just a fancy way of saying that. Okay. All right, so we're going to take our derivative, set it equal to 5. What's the derivative?
4x
Minus 3 equals 5. I want to know where the derivative is also the same slope.
4x equals 8.
4x equals 8.
X equals 2.
X equals 2. Now, is 2 a legit answer?
Yes.
How do I know that?
Between them.
2 lives in there, right? Okay, so I do have a place in that interval where he is going to have the same slope, and it occurs at 2, yeah? Okay. There you go. Do 7. I want to get one more done before the bell rings, or before we go to lunch.
What happens to the opposite value?
Just means it can't be 0 or a negative number. Well, it can be 0, but
Are you following the checklist?
Probably not.
No, you're not.
It's not the first thing.
What's the opposite value look like?
A v over 0.
V, which means he has a tippity tip. But where is the tippity tip?
On 0.
No.
I don't know.
What's the 5 move him?
Just kidding.
5 moves him to the
right.
right 5. So he looks like this. 1, 2, 3, 4, 5. So we're looking from 2 to 6. Is he differentiable from 2 to 6?
I mean, yes.
What does differential mean again?
Means you can take the derivative everywhere. Can you take the derivative everywhere from 2 to 6? How's come?
Because it's 5.
You can't take the derivative of the tippity tip.
Ah,
Yeah?
so no because of tippity tip.
So what do you put?
No.
Mean value theorem cannot be applied because of the tippity tip.
How do we take the derivative if it's not, if it is difficult?
I won't give you one like that, but the derivative of an absolute value is kind of like the derivative of ln. It's the main stuff underneath and then the derivative on the top. It's similar to that, okay? All right, last one, 8. Yeah, they want us to find maxes and mins and all these things. Okay, so do you guys like doing the table thing? Yeah, let's do a table. Okay, so I don't know how many sections I'm gonna have on my table, but I'm gonna do my intervals, my test point. I'm gonna do f prime and I'm gonna do f double prime, which is my first derivative, second derivative. Oh wait, we don't have to do second derivative. We're only doing increasing, decreasing, true? So I'm gonna do, instead of f prime, I'm gonna do conclusion. So that can tell me what he is, okay? All right, so there's that. I don't know how many intervals I'm gonna have. Let's do, what should we do first? What should we do first?
Find our critical numbers, right?
Yeah. So how do we do that?
Set equal to 0.
Derivative equal to 0. What's the derivative?
3x minus 3.
3x squared minus 3 equals 0? Ugh. Add the 3 over.
3x squared equals 3 divided by 3.
X squared equals 1. X equals
Squared equals
plus minus 1. So how many test intervals am I going to have? Gross. How many test intervals?
Oh, I was
3, right? We're going from negative infinity to negative 1. We're going negative 1 to 1. We're going 1 to infinity. Yeah? Okay, first test point. What shall we do? Negative 2 and 0 and 2. We're plugging in just the derivative, which is 3x squared minus 3.
So negative 2 times negative 2 is positive 4.
It's off the screen.
He's coming back. I don't know why he like times out on here. I don't know. Okay, so we plug in negative 2. 3 times negative 2 squared minus 3.
9.
4, 12 minus 3 is 9. 9 is positive. So he is increasing. Cool. 0. If I plug 0 in, 3 times 0 squared minus 3. Negative. Decreasing, because this is 0. 3 times positive 2 squared minus 3.
It's going to be positive.
Positive. Increasing. Okay, so let's do increasing. My intervals of increasing are from what? 2.
Negative 1.
Negative 1. What if I have 2?
Union.
Intervals. Union.
1 to infinity.
1 to infinity. Okay, decreasing. Negative 1 to 1. Okay, maxes and mins. Ooh. If he is increasing, then he is decreasing, then he is increasing. This is my visual. What's happening right here?
Max.
There's a max at negative 1. I'm going to say x equals negative 1. Did anybody plug it back in? Did you plug it back in? Okay. If you plug it back in, it's negative 1 comma, you said 2? Yeah? Negative 1 comma 2? Okay. He has a min at x equals positive 1, which is 1 comma, if I plug him back in, negative 2. Yeah, there we go. There you go. Okay, good?
Now we do it on our own.
Now you do 9. 9 should be easier because it's a quadratic instead of a cubic. So he'll only have 1 critical number. So 2 test intervals is all you'll have. So on number 9, you will either have no max or no min. You won't have one of each. Make sense? You either have a max or a min. Not one of each. Okay? All right. That's as far as we'll get today. We'll start 10 and the back tomorrow. Not tomorrow. Monday. Yeah? Okay. Goodbye, people watching this video.